So let's try again. So today we're going to do differentiate of exponential function. So first thing first, if I had y equals e to the power ax plus b, right? And I recognize this is a two function here. That is one function. And e to the power something is a function y. So there's two functions involved. When there's two functions involved, we use chain rule. So I'm going to call this part u. Okay? So that u equals ax plus b, u dash equals a. Y equals e to the power u, y dash equals e to the power u. Yeah? So we say dy dx equals dy du times du dx. What's dy du? Differentiate e to the power u, we get e to the power u. Yeah, we get e to the power u. Du dx is a. What's u? U is ax plus b times a. Is that okay? That's basically what I said just now. Derivative of the power comes to the front times by the original. Is it okay? Alright. Bear that in mind. Just like what we said last 2 weeks, in the exam, you don't have to write down dy du times du dx in this extreme detail. For introduction today, I'm showing you guys where it's come from. In the future, we can and we are expected to write down the results pretty much by inspection. Therefore, y dash will equal to 3x plus 4. Finish. That's all you need. All good? Is that okay? Derivative of the power comes to the front. What's the derivative of power here? 4. That's all you need. Finish. For this sort of thing, we should be quick like that. Why? Because this is always the part A of the bigger question. Here, 2 is a constant. Well, constant get multiplied by that function e to the power negative 9x. What's the derivative of the power? What's the derivative of power? Negative 9, right? So the answer is finish. Yeah, 2 times negative 9. The rest is just copy done. Next one, slightly harder. What do I do? What's the derivative of the power? Can somebody tell me? So if you have trouble visualize, right? I'm just going to write down like this. Right? What's the derivative of power? Negative half. Yes? Negative half e to the power. Then you're done. Is that okay? Let's have a look at the next one. Differentiate y equals this. Then obviously y dash is just 5 e to the power x. Because we say we differentiate e to the power x, we get e to the power x. From what we talked about yesterday, and I showed that on decimals. Next part, we want to find the gradient of the normal to the curve. Normal, not tangent, right? So when the question talks about normal, I need to think about, what do I need to think about? Whenever I think normal, m1, m2 equals negative 1, I need to think about that relationship. By now, we should be really get used to this sort of question. Find the gradient of the normal to the curve at that point. This sort of question is very commonly asked in the exam, either tangent or normal. So whenever we see tangent, normal, or gradient, we're going to differentiate. So what's the derivative? Y equals 3 e to the power x. What's the derivative? It's 3x, right? Yeah? and you can verify that using decimals. At the point 0, 3, so we say at x equals 0, the gradient is 3 e to the power 0 is 3, because e to the power 0 is 1. 3 times 1 is 3. Now, we know the gradient, we know the point. Oh, hang on, it's normal. So what do we need to change? We need to change from the new gradient. If it's tangent, you're done, right? Because the question is normal. So, one more thing. m1, m2 equals -1. 3, m2 equals -1, which means your new gradient is -1/3. Now you found your gradient, you found your point, now back to your turnout. So y minus 3 equals -x minus 0. I'm using that point gradient formula, which this one is directly from year 10. Then you go y equals negative plus 3. Then you're done. That's your final answer. All good? Any questions on this? Any questions? If yes, ask me later, okay? All right, next one. My question to everybody. Differentiate y equals this to the power 3. Which rule I'm going to apply? Is it chain rule, is it product rule, or is it quotient rule? Which rule am I going to apply? Is it product rule? When do I use product rule? When do I use product rule? What does the word product mean? Something times something. Is it something times something? Is this something times something? Yes. How? How is this something times something? I can't say multiply here. Yeah? Well, you can think like that, but it's not one bracket times another bracket. Right? Is it quotient rule? Is it division? Is it chain rule? Function of a function. I've got a function called 1 plus e to the power x. And I got another function based in the power of y. Therefore, that is a chain rule. Which we said 2 weeks ago. So, let u equals this. I call that u. What's du dx? What's u dash? It's just e to the power x, because with differentiate 1, we get 0. Yeah? Y equals u to the power 3. What's y dash? 3 u to the power 2. Yeah? Now, dy dx is equal to dy du times du dx. What's dy du? It's 3u squared, du dx is e to the power x. So the answer is 3 e to the power x, u copy down. Now once again in exam, you don't have to write in this extreme detail. What I have done is power comes to the front, differentiate the bracket, I get e to the power x. Copy down the bracket, power drop by 1. Which we should be get familiar with the process by now. So that's it. That's your final answer as a derivative. All good? People happy with that? No? Awesome. Okay. Whenever you get differentiation question, ask yourself, which rule? I've got 3 tools, right? Those are my tools. I've got chain rule, product rule, quotient rule. By the look of it, which rule do you think I'm going to apply? Quotient rule, perfect, because it is a quotient, right? Something divided by something. So let's write this down. Let u equals this, v equals this. What's u dash? 2. What's v dash?
Yes.
It's just the original function, right? Now, once I've identified those elements, then I'm in a position to apply quotient rule. Again, after enough practice, you will be able to remember quotient rule. However, quotient rule is on the formula sheet in HAC, right? So, y dash is vu dash minus uv dash over v squared. Be very, very careful. It's vu dash first, not uv dash. Again, this is in the formula sheet. Okay, so v is e to the power x. U dash is 2. I'm going to write the number before the letter. U is 2x plus 3. V dash is e to the power x. V squared. So it's e to the power x squared. Yeah? So I get 2e to the power x minus 2x e to the power x plus, minus here, minus 3e to the power x. I get e to the power 2x. Right on this part, I get minus e to the power x minus 2x e to the power x, e to the power 2x. Then I simplify. What's the common factor on the top? I get minus e to the power x here, minus e to the power x here. Therefore, I need to be able to identify that the common factor is minus e to the power x. So on the top now it's factorized skill. Back to year 9, year 10 now. So minus e to the power x is a common factor. I take it out. I get 1 plus 2x. Then e to the power 2x. I got e to the power x here. I got e to the power 2x here, which means one of those have to be cancelled. Again, this is the year 9, year 10 skill now. So the answer is minus 1 plus 2x e to the power x. Okay, all I have done is quotient rule, but towards the end, it's a bit of factorizing skills needed. All good? Let's move on. Okay, 2 parts of the question. First one's easy. Differentiate that. And then find out when x equals what, the curve is stationary. So let's do the first part first. So y is equal to e to the power x minus x, right? What's y dash? So it's going to be e to the power x minus 1. Very good. That's the first derivative. Just take a seat. So that's the first derivative. Yeah? Second part of the question asking when x equals what, the curve is stationary. This is a really important word in this chapter or in future chapter related to calculus. What does stationary mean? What does stationary mean? Huh? Not y equal to 0?
Not changing.
What not changing?
The
Gradient. Very good. So gradient is neither increasing nor decreasing. How do we represent gradient? How do we represent gradient? Y dash. Yeah? So it's not y, it's y dash is neither decreasing nor decreasing, increasing nor decreasing. So whenever you say the stationary, this is a really, really important word. It's indicating my first derivative is equal to 0. In other words, horizontal. Okay? So that's what that means. Whenever you say stationary, you think straight away. The tangent is horizontal, therefore y dash equal to 0. Therefore, e to the power x equals 1. X equals 0. E to the power, anything to the power of 0 is 1. Okay, I'll stop here.